Hello friends, in the last video we have seen how the pile group will behave. In the present video we will find bearing capacity of a piles in clays. We'll say it is a group pile capacity in clays. So what we have to consider the pile group pile capacity that will be lesser of, that will be smaller of n times individual pile capacity, comma group pile capacity. Already we have seen if it is in clays, how we can find out the single pile capacity. In the present video, we will see how to find the group pile capacity. Okay, let us assume that we are having some a square footing. Let us consider in the project site, they have decided to construct 9 piles and they should form a square shape. So first in the plan I am drawing, that means in top view if I see, the 9 piles will look like they are forming a square shape. This is when if I am seeing from the top view on the foundation. So these 9 piles, they are forming a circular square shape. Just like this. In most of the cases, the spacing between the columns, they will keep it as a constant. Let us assume the width of the pile group will be equal to capital B. On the other side also, as we are talking about the square shape. Okay, is it okay? Now, let us assume the spacing between the piles. That means center to center spacing between the piles is S. Okay, then what about the number of piles? What about the width of the square shape? So B, that will be equal to, how can we find out? That will be equal to, how many spacings are there? 2 spacing. How many piles are there? 3. That's why here I'll say x minus 1 into S. That means from here to here I am getting. So after that, the remaining portion plus D. Here x is nothing but a number of piles in a row. Here I'll say x will be equal to number of piles in a row, and S is nothing but a center to center spacing between piles. Center to center spacing between piles. What about the D value? D is nothing but a dia of a pile. In general, everything will kept uniform. Don't think that we'll have the different dia of piles. So in most of the cases, we'll have the same dia of the pile. This is when if you are looking into the top view. If you are seeing along the cross section, if you cut along the sun cross section and if you see it, so they will look like, there will be a pile cap that is connecting all the piles, and if I cut at any point, I will be able to see 3 piles just like this. On the pile cap, let us assume the load is acting Q. Now we have to find out if already we have seen how to find the capacity of a single pile. Now we have to find out if this combined, if the pile group that itself is going to be failure. That means if the block failure is happening, what is the capacity? That means all the pile itself that is start failing. That means like this complete part. That means imagine this complete square shape is moving in the downward direction. Then how they will look like? This surrounding. This part of the soil also is moving in the downward direction. Don't think that only piles will move. The whole pile group, including with the pile cap, that is moving in the downward direction. Then in this case, how to find the group pile capacity? nothing but a QUG, group pile capacity. Nothing but a end bearing capacity of a group pile plus frictional resistance of a group pile. So how to find the end bearing resistance? That will be nothing but a end bearing resistance QUG into a bearing area plus similarly a frictional resistance of a group into area of the group file, surface area of the group file. Is it okay now? What about the QB into G? That is nothing but a NC into NC. NC we have already calculated 9. What about the base area? So if the whole block itself is coming failure, what about the base area? That is nothing but your top view plan. What is the area of top view plan? If it is a square, B square. If it is a rectangle, B into D. So as it is a square shape, I will say it is a B square. Plus, what about the QS value? That will be nothing but a alpha into C bar into. What about the surface area of a group pile? If it is under block shear failure, what about the area here? We are having 4 different sizes. That means 4 into B over length of L. That's why here it will be 4 into B into L. So by using this relation, we will find out the capacity if there is a failure in the group action. That means also we can consider as a block shear failure. If there is a block failure, this is the capacity. What about in single pile? That means N into QUP. That will be equal to N into N bearing resistance 9 into C. N bearing resistance pi by 4 into D square plus frictional resistance alpha into C bar. Here it will be pi into capital D into L. So this is what based on the single pile. So the capacity of a group action of file will be considered less than of these two values. So this is about the evaluation of capacity of a group pile in clays. In the next video, we will see how to find the group pile capacity in sands. Thank you.